A very good morning, students. Today is the last class of the chapter determinant, and in today's class we will be discussing two very important topics, in which our first topic is a Cramer's rule. Again, a Cramer's rule. But in previous Cramer's rule, we had two variables x and y and two equations. But in this Cramer's rule, we will be discussing a set of equations in which there are three variables x, y, and z, and in the set of equations there will be three different equations. Now for that, let us consider a set of equations in which there are three variables. Consider the equation as a1x plus b1y plus c1z is equal to d1. Another equation a2x plus b2y plus c2z is equal to d2. And the last equation a3x plus b3y plus c3z is equal to d3. Here in this equation, set of equation, the variables are x, y, and z. And here a1, a2, a3 are the coefficients of x. b1, b2, b3 are coefficients of y. And c1, c2, c3 are coefficients of z. And d1, d2, d3 are constants. Now in this Cramer's rule also, the value of x is given by dx by d. Value of y is given by dy by d again. And the value of z is given by dz by d. This is the formula of Cramer's rule. Now, what is d, dx, dy, and dz? Now, in previous Cramer's rule, these all determinants d, dx, dy, and dz are determinants of order 2 because there were only two variables. But in this set of equations, there are three variables x, y, and z. So that's why the order of these three determinants will be 3. So here determinant d is again a determinant of coefficients of x, y, and z. This determinant is a determinant of which order? Order 3, in which our first column will be the formed by the coefficient of x, and second column is formed by the coefficient of y, and the third column is formed by the coefficient of z. Now similarly, dx is a determinant in which first column is the constant terms d1, d2, d3, and second column is the coefficient of y, and third column is the coefficient of z. Again dy. Here dy is a determinant of same order 3, in which first column is the coefficient of x, second column is the constant term. And third column dz is the coefficient of is a determinant in which the third column, that is a column formed by the coefficient of z, is replaced by the constant term d1, d2, and d3, and the other two columns remain same. a1, a2, a3, b1, b2, b3. Now let us try to solve question number 4. First part, this is related to the extended form of Cramer's rule. So here the variables are x, y, and z, and this is a system of linear equation consisting of three equations. So now let us find the value of x, y, and z. So first let us find d. D is a determinant formed by the coefficients of x, y, and z. So here plus 1, minus 3, and here 2. Here 1, 5, minus 4. Now expand this determinant. So you'll get 4 3 is 12. Minus 10. Minus 1. 8 minus 5. And here plus 1 4 plus 3, so which is equal to 2 minus 1 of minus 13 plus 7, which is equal to 2 plus 13 plus 7. 13 plus 7 is 22. Here the value of d is 22. Now similarly, let us calculate the value of dx. We know that dx is a determinant in which our first column is the constant terms and second column coefficient of y and third column coefficient of z. 1, 5 minus 4. Now expand this determinant. 12 minus 10 minus 1 minus 16 plus 5 plus 1, 8 minus 3, so which is equal to 3, 2 minus 1 into minus 11 plus 1 into 5, 6 plus 11 plus 5, 5, 6, 11, 11, 22. So the value of dx is also 22. Now let us calculate the value of dy. dy is equal to, in dy you have to replace the second column of this coefficient matrix by the constant terms. So in that process, first column will remain same, that is the coefficient of x. In second column you have to replace terms by the constant terms, and in third column you have to write the coefficient of z. Now expand this determinant. Minus 16 plus 5 minus 3 minus 8 minus 5 plus 1 minus 2 minus 4, so which is equal to 1 into minus 11 minus 3 minus 13 plus 1 into minus 6, which is equal to minus 11 plus 39 minus 6, which is equal to 39 minus 17, so which is equal to 22. So the value of dy is also 22. Now our last step, find the value of dz. dz is equal to, first column and second column will be the coefficient of x and y. It's not y, right here 1 minus 3, 2, and in third column you have to replace by the coefficient of the constant terms. Now expand this determinant. 3 minus 8 minus 1 minus 2 minus 4 plus 3, 4 plus 3, which is equal to 1 minus 5 minus 1 minus 6 plus 3, 7, which is equal to minus 5 plus 6 plus 21, which is equal to 1 plus 21 is equal to 22. So here the value of dz is also 22. Now apply Cramer's rule to find the value of x, y and z. By Cramer's rule, x is equal to dx by d, which is equal to, what's the value of dx? 22. And what's the value of d? 22. So 22 ones are 22. Similarly, calculate the value of y. Formula is dy by d. So what's the value of dy? 22. And what's the value of d? 22. So 22 ones are 22. What's the value of z? Dz by d. So here dz is 22 and d is 2. So therefore value of x is equal to 1, y is equal to 1 and z is equal to 1. Therefore x is equal to y is equal to z is equal to 1. This is your solution of this set of linear equations.